All right, we are going to finish up section 2.7, solving problems involving money. And this is very similar to a mixture problem. In this case, instead of drawing buckets, I drew a quarter and a nickel. Actually, I copied and pasted. We're going to add these together, just like we were doing with the buckets. Now, with the final bucket, if you will, you're generally not going to multiply a rate times an amount, okay? Generally, you're going to have a total amount of money, $2.55, and that's it. That's no, you're not going to take an amount times a percent or a rate. All right, so we've got quarters and nickels. We've got 9 more nickels than quarters. Notice we described the nickels, but we did not describe the quarters. So the number of quarters we have, we're going to call that X, and the number of nickels, we're going to have 9 plus X. And we know that a nickel is worth 5 cents. Be careful with this. Don't put 0.50. That would be 50 cents, so 0.05. And quarters are 25 cents each. And we're going to multiply, add, multiply. But again, we're not going to multiply anything times this one. It's just going to be the total amount of money. So 0.25x plus 0.05 times x plus 9, don't forget the parentheses, is equal to $2.55. So this is the amount of money we have in quarters. This is the amount of money we have in nickels. And all together, meaning add, we have $2.55. Let me check to see if I have, yes, here we go. So again, we're going to multiply by 100 to get rid of the decimals. And that gives me 25x plus 5, x plus 9, 255. Distribute the 5. Don't forget to multiply the 5 times the 9. Combine like terms. And not yet. We're going to subtract the 45. Now we're going to divide by 30. Remember, if it has a single 0 and a single 0, that's equivalent to dividing by 10 if I cross out those zeros. So now I have 21 divided by 3, which does give me 7. And again, we have to make sure we answer the question. So how many nickels, how many quarters? So x was equal to 7, which tells me I have 7 quarters. And 9 plus x is the nickels. So 9 plus 7, or 16 nickels. All right. Distance, rate, and time. Okay, this is the distance formula. It's written in 3 different ways depending on kind of the information that's given and how it's set up. So if it says something along the lines of the time is the same for 2 different vehicles, then you would use this formula. This setup for the formula. If it says something like the rate is the same for 2 different vehicles, then you would use this one. All right, so D equals RT, or rearrange it, R is equal to D divided by T, T is equal to D divided. It's all the same formula. Okay. Usain Bolt of Jamaica ran the men's 100-meter dash in 2012 in 9.6 seconds. So the time is equal to 9.63. What was his rate? So we know the distance is equal to 100 meters. And so we know that 100 meters is equal to the rate times the time, 9.63, and we're going to divide by 9.63. And I don't know what that is, so I'm going to check my calculator. 100 divided by 9.63 gives me, rounded to 2 decimal places. Make sure you round correctly. 10.38. And we're talking meters and we're talking seconds. So the unit actually would be meters per second. Meters per second. Okay, so this is just a straightforward distance is equal to rate times time. We're only talking about one person. We're not talking about two different vehicles, two different people. The straight distance equals rate times time. However, now we're talking about two different airplanes. When we have two different things going on, a table is the easiest way to organize the information. And so we've got a slower plane and a faster plane, and they leave at noon and they fly in opposite directions. So it's kind of helpful if you just draw a little something like that to indicate. So here's my Boston, and one is going in this direction, one is going that direction. Again, make sure that your arrows are not the same length because one is going to fly faster than the other, one's going to go further than the other. So one flies at 410 miles per hour, that's a rate, and the other flies at 530. So the slower guy is 410, and the faster guy is 530. By the way, don't forget, rate times time is equal to distance. How long will it take them, and at what time will they be a total of 3,290 miles apart? All right, so we don't know how long, but they do leave at the same time. So the time is going to be the same for both of them, okay? So rate times time is equal to distance. So 400 times t, this will be my distance for the slower plane. And rate times time, this will be my distance for my faster plane. And they're going to be a total of 3,290 miles apart. So total, remember total, generally, we're going to be adding things together. And we are 3,290, okay, total. So next slide so that I can, I have some room to solve it. So we're going to combine the t's. What do we got? 940 t is equal to 3,290. Divide by 940. And we have, let's see, 3,290 divided by 940 gives me 3.5. So it says miles per hour, so that means that the time has to be in hours. Now, again, we have to go back and check to see if we answer the question. It says, how long will it take them? That's our 3.5 hours. And at what time? Okay, so at what time? So it left at noon. What time would it be 3.5 hours later? So at 3:30 p.m., they would be 3,290 miles apart. Okay. All right, again, we've got two buses. So we've got a slower bus and a faster bus. They almost never travel the same speed. So they're going in opposite directions. So again, we've got one going this way and one going this way. One had a speed of 10 miles per hour faster than the other. So I don't know what my rate is, but this guy is 10 miles per hour faster than the slower guy. 12 minutes later, it has to be, we're talking miles per hour here, so we have to deal in hours. So if we've got 12 minutes and we know that there's 60 minutes in an hour, that would give me 1/5 of an hour. So 1/5 and 1/5. And they're going to be, again, we're going to be a total of 12 miles apart. So again, we are going to add the two distances together and get a total of 12. Again, rate times time, rate times time. And we're going to add these together because they're a total of 12 miles apart. And yep. Okay, so fractions, right? Remember with the fractions, to eliminate the fractions, we're going to find the least common multiple between all of our denominators. So we've got a 5, a 5, and a 1. So our least common multiple is going to be 5. Don't forget to multiply over here. And we cancel and multiply. Cancel. Wait to distribute. If I just distribute a 1, I just end up with r plus 10. 2r plus 10, combine like terms, and subtract our 10. 50, and divide by, my brain's tired, r is equal to 25. Now, again, we got to check to see if we answer the question. We got to make sure we answer the question. So what were their speeds? So we need both of them. And we said that R was 25. And again, we're dealing with miles per hour. And so the faster one is going 10 miles per hour faster. So this would be 35 miles per hour. Slower bus is 25 miles per hour. Faster bus is 35. Okay. So that is the end of section 2.7.